This is the 2020 Ordinary Level Pre for DCG, question B2, Axonometric projection. So if we look at the question, the graphic on the right shows a perfume bottle. Figure B2 below shows an incomplete isometric projection of a similar perfume bottle. The elevation and plan of the perfume bottle are also shown in the required positions. This question has 4 parts. Part A is to draw the given equilateral triangle ABC and the axonometric axis X, Y, and Z. Part B, draw the elevation and plan positioned as shown. Part C, draw the axonometric projections of the main body of the bottle. And Part D, draw the axonometric projection of the cylindrical lid of the bottle. This scale is 1:1. Just something to note before you start setting this question up on your page. If you're using an A3 page, this is quite large and it may not fit properly. So to get the best use of the space, if from the top of the page come down 130 millimeters, and that can be your center point here for the axis X, Y, and Z. So I'm going to use that point there. Left, right, maybe slightly left of center. So just come down 130 millimeters from the top of the page and pick a point there somewhere, and that will be the center for our axis. So what we're going to start with is setting up the axis X, Y, and Z and drawing the equilateral triangle ABC. So this is my start point, and from here I'm going taking a line at 30 degrees off up to the right, and it's going to come below it, 30 degrees this way, 30 degrees coming down to the right, and a vertical line coming up. That gives me my axis X, Y, and Z, and is the first part of part A. The second part of this is draw the equilateral triangle ABC. ABC, we're given one side length, and that's 100 millimeters. And because it's an equilateral triangle, we know that the angle is going to be 60 degrees, and if our side length is 100. So what I'm going to do is I'm going to measure 50 millimeters left and right, so I know the length of the line down here is going to be 100. So if I measure 50 to the left and 50 to the right of that, I can find where they are on my sloping line down here. So the distance now between these 2 points that I've just marked is 100 millimeters, and so I'm going to end up with the correct position for my equilateral triangle. Okay, so just draw a light line there. Next part of this then, as it's going to be 60 degrees, I can take 60 degree line off up along this way, and 60 degree line off up along here also, and they will intersect, and that gives me my axis. So this is 100, 100, and 100, and I'll just label the points as they were given in the question. A, B, C, and this is the y-axis, x-axis, and z-axis. So that's the first part of this given question. Looking again at the next part of this, part B is to draw the elevation and plan positioned as shown. So I'm going to start by drawing the elevation, and the elevation is going to come off up here to the right. So to start that next part, what we're going to do is going to continue by projecting lines B and C out along here at 30 degrees, the same angle that we used for along here, so 30 degrees and 30 degrees. So the next thing that we're going to do is we're going to draw a line that is out here, that is perpendicular to the lines that we've just projected out. So it's going to be at 60 degrees in this case. Now the position of that out along here is not important. I'm just going to measure out about 100 mil because I know that'll fit on the page. So if you measure out 100 mil, and we'll just draw light lines coming across that there. So if you had, if you're using the larger A2 page, you don't need to worry about that. So out at least 100 millimeters. Next, what we're going to do is we're going to draw the axonometric, the planes, the edge view of the planes. And to do that, we need to draw a semicircle. And because this is isometric, this distance and this distance are going to be equal to each other. So we're just going to draw our semicircle, it'll touch off both sides. And there we have our semicircle. What we need to do next is we're going to join the point from here down into the center. So again, light lines, these are just setting up the axis, and same coming down this way, giving me my angle that I'm going to be drawing my elevation in shortly. So just recapping what I did here, project the lines B and C out at 30 degrees, the same angle as the x-axis is at. I put a line perpendicular to that, about 100 millimeters out from the line BC, just for space on the page. And then I was able to draw a semicircle around the center point, which is here. So semicircle touching both of these corners. Where the semicircle cuts the line coming from X is going to be a point on my 90-degree bend, so I'm going to come my line down along here and out along there also. So what we're going to do next is we're going to draw the overall shape, which is the elevation of the block of the perfume bottle. So for that, we're given a length in the question of 80 millimeters out along this way, an altitude of 50. So we'll draw both of those and mark them. And then using your sliding set squares or your adjustable set square if you have one, we'll set up the block part of this here. So that's the overall base, the bottom part of that block. So we can darken in those bit of lines here. And up on top. The next part of this is the cylindrical piece, that's the cylindrical lid. That is centered. If we look, we have a center line running down through the middle of it, so that's going to be positioned in the middle, and that has a radius of 24. So I'm going to measure 24 either side of the center point that I just marked. So as this is a cylinder and we're looking at it from perpendicular to the axis, it is going to be just appearing as a rectangle, has a height of 25. So we can draw in that rectangle. And that's the elevation complete. Next part of this, I need a plan. So the plan is going to go down underneath here, the usual place a plan goes. So I'm going to project my lines down from A, B, and C. And I'm going to draw the same semicircle that I drew a moment ago. A, B, and C. For this one, if you come down approximately 80 millimeters from the line AB and draw your horizontal line, everything should fit on the page there. So drawing my horizontal line again, the distance from AB down to here I used was 80 millimeters. So again, we're going to need to draw a semicircle. This point here will be the center for our semicircle, and it is going to come back up into the top. So semicircle. Semicircle, where it touches the line coming from C now is going to be part of our axis, so it's going to be a line coming out this way. Same going the opposite direction. And this is the axis that we're going to be drawing the plan of the object in. So again, it's going to have the same dimensions. It's going to be 80 millimeters down along this way. It now has a thickness that we need to take into account of 48 millimeters. And our lines here are at 45 degrees. So just darkening in the outline. That gives us that part of it. The next part of this is we need to find the center for our circle. So that's going to be along here 40. And then it's positioned partway between the two, so it's radius of 24. So that's 48, radius 24, giving me the center point there. And let's draw that circle one more time. Alright, so that is part B of the question now complete. Draw the elevation and plan position as shown. Just recap on what we did. Position, took points A and B, projected them vertically down, so parallel to the axis coming down along this way. I needed to draw a semicircle. That semicircle starts on the center point here with a radius off out to the side, so from halfway between A and B. That's my radius for the semicircle. Where the semicircle cuts the center line, the middle line coming down, I'm going to join that to the two corners, so here out to along here, giving me my angle that I need to position my plan. Next part for question part C is to draw the axonometric projections of the main body of the bottle. So we're going to draw the 3D version of the bottle sitting inside in the crow's foot area. So we're going to be projecting our lines from up here and up here to get the 3D version of it sitting here in the middle. To do that, we're going to take each of our points, each corner, and project them up. I'm going to start with the ones that they give us in the question already done, and that's this point and this point down here. So we're going to take this, project it up. So all our lines from the plan are going to come vertically up. All the lines from the elevation are going to come down at 30 degrees. So line is projected up along here. This point, as we can see in our 3D object, is sitting on the ground. So this is going to be one point that a part of my object. The other one is going to be up above it. So to find that, I need the height, and the height I'm going to take from the elevation. The height is projected down from my elevation. That's this point in the corner, comes down to intersect it, giving me this point here. So I now have one side or one edge of one of the sides of the object. Now, the next part of this, I'm going to start working my way around. So if I take this point and project that one up, that intersects with the line coming from that bottom corner. That gives me this one. That also has another point directly above it, same as what we had over here. So this gives me this front edge, the small side, as given in the question. So I have this side drawn here. The next bit I'm going to draw is the large front face, which is going to be this edge along the bottom. Again, following the same idea, the same principles, I'm going to take my corner and project this vertically up. It's going to give me a low point and a high point. The low point is going to be on this one down here, and the high point is going to be coming from the top back there. To know you've drawn accurately, this point and this point should be lining up. Same with them down below. And this gives us the front part of that object. Final part of this now is just the top edge, finding that back corner, which is given to us here. And I'm just going to draw the line in lightly first, and we can darken it in later on because we will have more to do in relation to the cap. There will be some bits hidden. So the final part of this question is drawing the 3D version of the lid, and that's based on a cylinder. To draw the cylinder, we need to get points on the cylinder on the circle, as it has no edges like we had for our clear edges, clear points along the top surface that we can use, just like we had for the block. So what we need to do is we need to divide the circle up in plan and elevation up into the same number of parts. So in plan, I'm dividing that up into 8 parts. You can use 12, I wouldn't use less than 8. And then we're going to label those 12 points. So I'm just going to start working my way around to 3, 4, 7, and 8. That gives me 12 points, or 8 points. These 12 or 8 points I'm going to use now up in the elevation, and I need to find the exact same 12 points. So as I'm looking, my elevation looks in at it this way. Point 1 and 5 are going to be here on the front. Point 2 is going to be this distance off out to the side of it. So point 2, if I measure the distance, if I bring 2 out onto the front elevation, this distance from 1 out to the side will be the same, out to 8. This distance here is the distance that I need to mark up over here. So I can measure that distance with my compass or just with your set square. Measure that distance and mark it out here either side. So that gives me point 2 and 4 and 3, and this is 8 and 6 and 7 out here on the side. Now we need each of those points on the top and bottom of the cylinder. So project them down. So I now have all the points and information that I need to draw the curves here. So what I'm going to do is I'm going to take each point in turn, so I take each one individually, and I treat each point like they were a point on the corner of a block. So if I was to take point 1 first, which is this one down here at the very front, it's also along the front edge of this here, top and bottom. So I'm going to take this point and project it up into the elevation. So it's point 1 is going to be somewhere along that line. How I find where point 1 is in the elevation, or in my axonometric, I'm going to bring the heights down. That's 1 point. And then I also have it up on top. That's the other point for it. I'm going to do the same thing now with the next point. So if we take point 8, that's going to be projected straight up. And point 8 is now off out here on the side, 8 on the ground and up top. So projecting it from the low point, mark it, that's 8, and from the high point, point 8 here also. Continuing on, following the same steps, working my way around, point 7. 7 is at the very outside, so 7 is going to come down the same way. So follow it up. This is point 7. Down low, and point 7 up high. So continuing on with each of these points, point 6 back here will be the last one that I'll be able to see on the ground. Point 6 and point 8, if we look in our elevation, are in line with each other. So that means they're going to be on the same line coming from the elevation. So point 6 following that up, that's this one. And also this one up here, 6 and 6. Just to give an idea as to what we can do now. So you can join these points up with the best fit curve that you can. 6 and over here to 1. You can do the same thing up top or wait for a few more points. So this is going to continue down around this way. And all we're doing is plotting the points, and they're going to form or start forming our cylinder. So we still have the other half of the points to go. So point 5, again, that's projected straight up. In plan, it's in line with point 7. And it's in line with point 1 from up here. So this is going to be point 5. We can't see point 5 down low, so we don't need to move that one. So that's point 5. Point 4, same idea. Point 4 is projected straight up. So 4 here in plan, vertically up, 4 here in the elevation, down at your 30 degrees. That's point 4. point 3 done the same way. So point 3 comes vertically up, down at 30 degrees from the elevation, and this is point 3. And then finally point 2. Now point 2 I can see up high and down low. So point 2 is brought out. So this is point 2 down low, and point 2 up high is this one. So all we need to then is join the points up, forming our curve. Now, as 2 and 6 are tangent edges, they're the widest parts, there are just 2 vertical lines drawn from there. So, just a quick recap on that. We have the each point, we divide our circle up into 8 or 12 parts. 8 works well here as it gives you the outside edges. We copy the distance, the widths looking in this direction, up here into the elevation. So from my center out to point 2 was this far, same on the opposite side. And we're going to take each point in turn and project it up into the axonometric view. So if I take point 1, that line came straight up along here. I'll highlight it just to make it a little bit clearer. Point 1 comes straight up this way. And it also comes down in 2 positions from the elevation. It comes down up high, giving me that point. And it also comes down the bottom of point 1, the bottom of the cylinder, giving me the other point of it. So that gives me both this point here and the point down low. The only thing that needs to be done now is just darkening the bits after we've determined where the cylinder is. So we still have part of the block here that needs to be darkened in. So that's going to come back along this way until it touches the edge of the cylinder. And same for the bit coming in from this side. So just have one more look at the question. So part A is done, part B we have drawn, part C we've drawn the axonometric projections of the main body, and we've now drawn the projections of the cylindrical lid of the bottle. So there you have it. That is the completed question, the pre-question 2020 B2.